EduStick makes learning fun and it sticks. I'm Athleen G, and my background in teaching has been over 30 years. I work with young kids all the way up to adults, and I do math trainings everywhere. Okay, what I'm going to start off with is multiplying a two-digit number 12 times a two-digit number 13. I'm going to go ahead starting on the ones place. 2 times 3 gives me 6. 1 times 3 gives me 3. I'm going to go ahead and put a placeholder. 0 times 1 times 2 gives me 2. 1 times 1 is 1. I then add, and my answer is going to be 6 plus 0 is 6. 3 plus 2 is 5, and bring down the 1. This method is called the algorithm. Next method, very similar, but I'm going to expand it, and I'm going to rewrite 12 as 10 plus 2 times 10 plus 3. Instead of multiplying by the ones, I'm actually going to multiply 10 times 10, which will give me 100. Then I'm going to go ahead and multiply the ones, which is the 2 times 3, which will give me 6. Then I'm going to go ahead go through the diagonals, which is 2 times 10 gives me 20, and then 10 times 3, which gives me 30. Add it all up, bring it 0 plus 6 plus 0 plus 0 gives me 6. 0 plus 2 plus 3 will give me 5. Add up the 1, and this method is called the expanded notation. Now I'm going to go ahead and shift and bring in our base 10 board and explain how to do it with base 10, multiplying double-digit numbers. All right, before we start, we want to explain what a base 10. This is called a 1 unit because it's a 1 by 1. When you multiply 1 by 1, the area will give me a 1 unit tile. The next one is represented by this whole tile, but you'll notice I would go ahead and place 10 unit tiles alongside, and it will be equal to 10 units around it. So this will be 1 by 10. When you get the area of that, this is going to be called a 10 tile. Place 10 across this 10 tile to represent that when you put 10 of these across, 10 by 10, which makes this a 100 tile. A border to place the base 10 to represent the numbers. The first one I'm going to build is 12. So I'm going to place 10 and 2 1 tiles. And notice this is a 10 plus 2, which equals 12. The next one, I'm going to go ahead and put the dimensions down below, and I'm going to go ahead and build a 10 plus 3 units, giving the number 13. Again, that was 10 plus 3, which equals 13. I'm going to go ahead and complete the multiplication by representing that. All right, a 10 tile times a 10 tile will give me an area of 100. A 10 tile times a 1 will give me a 10 tile total. 10 again times a 1 will give me a 10 tile. I'm going to go ahead and fill in the next one. A 1 times a 10 tile will give me a 10 tile. 1 times 10 will give me a 10 tile. Now, the last part is a 1 times a 1, which will give me a 1 tile. And a 1 times 1 again will give me a 1 tile. Bring that across. And the last one's 1 times 1 gives me this value. Now I'm ready to go ahead and show the area. Okay, let's go back to our original problem with our expanded notation. If you look at that, we start off with 100, 10 by 10. We clearly see there's a 100 tile right there. We clearly see on this side it's a 20, the area. Here you clearly see there's 30, and all those equal 6. Our base 10 is a lot closer to the expanded notation. We don't see the same thing with our algorithm. What's the major difference? Algorithms are meant for speed. Expanded notation and the base 10 method are showing properties such as distributive and commutative property, which are essential for mathematics. Very important to see that concept and the visualization. So I'm going to go ahead and write down rectangular array. And I'm going to start off a 10 by 10 like a magic square will give me 100. A 10 times 2 will give me 20. A 10 times 3 will give me 30. And the last one, 2 times 3 is 6. Okay, if you notice again, these numbers reappear on the base 10 section as well as the expanded notation. And you'll also notice that the 10s are similar in the diagonal. Now I'm ready to go ahead and add. I'm going to go ahead and add 100 plus 20 plus 30 plus 6. I'm going to bring those two first. That'll give me 50 plus 6, bring everything down, and I'm ready to finish it up and get 156. That's called the rectangular array, and all the 4 methods will help you understand conceptually mathematics. That is what Common Core is about, making sure you have the understanding of the mathematics.